Hello class, we're about to start lesson 3-2, like a snowball rolling downhill. Our learning objectives is to describe how compound interest differs from simple interest, to develop compound interest formulas, and to use compound interest formulas to analyze financial issues. Now if we come down here to our syllabus, we have section 3.2. We're supposed to do page 218, 221, and 223. Okay, so now we will get started. It says we've already studied how an investment can grow when simple interest is calculated. The table below is borrowed from lesson 3.1, borrowed, stolen, whatever. In this case, a principal amount of $600 was invested at 5% interest. Our first goal in this lesson is to recalculate the interest earned and value of the account, this time calculating the next year's interest on the entire value of the account, including previously earned interest, rather than just on the principal amount. Okay, so what we would end up doing here is first we will go over the problem number 1. It says compute the amount of interest earned during the second year if that amount is 5% of both the principal amount of $600 and the $30 in interest that was already earned in the first year. Find the new ending value as well. Show work, please. Okay, so we know after the first year it was $630 in the account. And then we're supposed to multiply this by the 5% interest. And when we multiply this, it will give us $31.50. Okay, so now they said they want the ending value as well. So this is how much interest we will earn, but we will have to take the $630 and add on the $31.50, which will give us $661.50. Now, if we look back at this table, year 1 was $630, year 2 was $660, but here we will gain an extra $1.50. So this is actually turning out to be better as far as your savings account is concerned. Now we go to number 2. We know from lesson 3.1 that we could compute the amount of interest earned in 1 year using the formula I equals P times R. This is using T equals 1 in the formula, in the interest formula I equals PRT. Use the formula with P equals 630 to show that you get the same answer you did in question 1. So as interest is equal to principal times rate times time. The interest is equal to the principal, which is $630. The rate is 0.05 and the time is 1 year. Now when we multiply all of this out, it will give us $31.50. Okay, so as you see, we got the same answer. So we can basically use that same formula if we so choose. Now we go here to number 3. It says use your answer from question 1 to fill in the row of the table corresponding to after 1 year. Then repeat your calculations to fill in the remainder of the table, keeping in mind that in each case interest should be calculated on the new amount at the beginning of the year. So we know after year 1, we will have $30. And we know that will leave us $630. Now, when we put this in our calculator, as we did in question number 1, that gave us $31.50 in interest. So we would add 30 plus 31.50, which would be 61.50. And then the value of the account will be $661.50. Now, we could go off to the side. Remember, this is all 1 year, so we could just do P times R without doing the T. So it'll be $661.50 times the 0.05, which will give us $33.08. So we will add that here. This will give us $94.58. And then now the value of our account is $694.58. Now we would do the same, $694.58 times the 5% interest. And that would give us $34.73 in interest. So now we will have $129.31. And we will add that to the 600, which would be $729.31. And that's how much we will have after 4 years. Okay, now if we went back after 4 years here, we had $720. But using this type of interest, we got an extra $9.31 without doing anything extra. If all went well, you should have found that at the end of 4 years, the account will have $9.30 more when interest is calculated on the new yearly amount rather than the original principal. This type of interest is called compound interest. And each time the new amount is calculated, in this case at the end of each year, we say that interest has been compounded at that time. Since interest is being compounded once per year in this example, we say that it is interest compounded annually. You're probably not overly impressed by the extra $9, but when we develop some formulas for efficiently computing compound interest, we'll be able to see that something very interesting happens in the long run. So let's get to work on developing a formula by looking for a pattern. Okay, now we move on to the next page. It says value after 1 year. We will add the principal times 1 plus 0.05. Value after 2 years. Value after 1 year times 1 plus 0.05. And it's shown here in this equation. Now it says now fill in the boxes in the computation to find the value after 3 years. So value after 3 years, the value after 2 years times 1.005. So then what will end up happening here, this will be 600, which is the principal, times 1 plus 0.05, and we would take that to the second power. And then we will multiply that value times 1 plus 0.05. Now to see where we got this value from, this was our end result here for value after 2 years. So we substitute that value for the value after 2 years. So to get our third year, we would just have to take 600 times this parenthesis to the third power. Now here comes the key observation of this lesson. So fasten your seat belts. So far we know the following: the value after 1 year, the value after 2 years, and the value after 3 years. If you notice, as the years increase, the exponent on the parenthesis increases as well, because this is assumed to be taken to the first power for the first year. It says make a conjecture as to the value after 4 years and 5 years. So we will do the same here. The parenthesis will remain the same, but the exponent here would be 4. And then for the 5th year, the 600 in the parenthesis will remain the same, but the exponent will go to the 5th year. Make a conjecture as to the value after t years, where t represents any number of years. Value after t years, you have 600 times the parenthesis 1 plus 0.05, and it'll be taken to the t power. Congratulations, your conjecture, you did get it right, can be formalized into our first important formula for compound interest. So we have the formula for compound interest compounded annually, which is this formula here. A is the future value, P is the principal, R is the interest rate, and T is the term, or the time in years. So number 7. Oh, and by the way, on your one sheet of notes you're allowed to use on your exam, I would definitely put this formula on there as well. Okay, number 7. It says use the formula for interest compounded annually to find the future value of the original $600 investment at 5% interest after 10, 20, 30, and 40 years. Then use the simple interest formula from lesson 3.1 to find the future value if the interest is simple. Okay, so this is what we would do. The future value compounded annually, we will use this formula. A equals 600 times 1 plus 0.05 to the t power. And then for the simple, we will have A is equal to 600 times 1 plus 0.05 times t. Now, when we put in these values, and I will show you all this in a calculator. So we will go right to our calculator. And let's do the future value compounded annually. So we will have 600 parenthesis 1 plus 0.05. And we will have that taken to the 10th power. And that will give us $977, and we would say 34 cents. Because remember, with our money, we only go 2 decimal places. Now we will try this with 20 years. Now I will show you a little trick on the calculator so you do not have to keep typing this in. So press second and enter. And if you notice, it pulled down the same exact equation that we typed before. Press the back arrow and change that 10 to 20 and press enter. So that'll be $1,591.98. So we'll press second and enter again. This time we will go up, type in 30. So it'll be $2,593.17. Do the second and enter again, but this time we will do 40 and press enter. It'll be $4,223.99. Now we go over here to the simple interest. We could do the same thing, press second and enter, but we're going to have to change a little bit. You'll press delete to get rid of that parenthesis, and delete twice to get rid of that parenthesis. Well, 3 times to get rid of it totally. Now, we know that inside this parenthesis it'll be a t. So this will be times 10. And we will close our parenthesis and press enter. So this will give us $900. And we'll press second and enter. We'll change that 10 to 20. And press enter. That'll give you $1,200. We'll press second and enter again. Change that 20 to 30. And that will give us $1,500. And then second and enter again. Change that 30 to 40. Press enter. That'll give us $1,800. And as you see, there's a significant difference between the compound interest versus the future value. And it's really prevalent when we come to that 40-year mark. It says here, use the table to draw a graph of the future value for both accounts. Then write a verbal description of what you learned from the table and the graph. Make sure you choose an appropriate scale for each axis. And of course, label that scale on your graph. Do something to distinguish the two graphs. Use different colors or make one dashed or thicker. What kind of growth does each account illustrate? Okay, so first of all, we need to look here at our x-axis and our y-axis. Okay, so now our x-axis would be the years, which we have here. The years go from 10 to 40. So if we look here, we have 5, 10, 15, 20, 25 tick marks. So I would suggest we go by, let's see, 2s. So this will give us 10, this will be 20, 30, 40, and then 50. And that will cover all of the values. Now as far as the money is concerned, it goes anywhere from 900 to 4,200. And I would suggest we go